Hello, welcome to Chapter 7, homework questions 54 through 60. Question 54. Use the information given for each diagram below to solve for x. Show all your work. Part A. Ray BD bisects angle ABC. So, ray BD bisects angle ABC. So that means that these two angles are congruent. If ABD is 5x minus 10 and ABC is 65 degrees, solve for x. So since we know that ray BD bisects them, we know that both angles are in the form of 5x minus 10 degrees. And if we know the sum of those add up to 65, then we can set up an equation 2 times 5x minus 10, or you can just add that together twice, is equal to 65 degrees. So 10x minus 20 equals 65. Subtract or add 20. So 10x is equal to 85 divided by 10. X is equal to 8.5 degrees. Part B, point M is the midpoint of EF, line segment EF. So that means that EM is congruent to MF. And it says EM is 4x minus 2, and MF is 3x plus 9. So since we know they are congruent, we can set them equal to each other. 4x minus 2 equals 3x plus 9. Subtract 3x, add 2 to the other side, and x is equal to 11. WXYZ at right is a parallelogram. So if we know it's a parallelogram, we know some information about the opposite sides being parallel. If the measure of angle W is 9x minus 3 degrees, and Z is 3x plus 15 degrees, how can we solve for x? Well, we also know that these angles are same side interior, so we know they are supplementary. So we can rewrite this as 9x minus 3 degrees plus 3x plus 15 degrees is equal to 180 degrees because they're supplementary. So we combine our like terms. That's 12x plus 12 degrees equals 180 degrees. Subtract 12. And that's 168 degrees, and then you can divide by 12. And that will give you x is equal to 14 degrees. Question 55. Jamal used a hinge mirror to create a regular polygon like you did in lesson 7.1.4. If his hinge mirror formed 72-degree angle and the core region in front of the mirror was isosceles, how many sides did his polygon have? So if it's an isosceles triangle with 72 degrees, then you know that 360 degrees divided by 72 degrees will give you how many of those triangles you had in there, which gives you how many sides that you also had. So that is equal to 5. So that means you have 5 sides in your regular polygon there. On part B, now Jamal has decided to create a regular polygon with 9 sides called a nonagon. If his core region is again isosceles, what angle is formed by his mirror? So now we can go the other way. We still know it's 360 degrees, but now we know that there are 9 sides. And so if you take 360 divided by 9, you will get 40 degrees, and that's the angle that is formed by his mirror. 56. Sandra wants to park her car so that she optimizes the distance she has to walk to the art museum and the library. That is, she wants to park so that her total distance directly to each building is the shortest. Find where she should park. So we can use our optimization technique in our straight line, and we'll reflect the art museum to the other side to make that 50 feet. And then we can create a straight line to the library. And so if the whole thing is 80 and we call, this side length x, then we know that 80 minus x would be that length. We also know that the triangles are similar. we have right angle, and we also have vertical angles. So by angle similarity, we do know they're similar. So we know that their sides should be in proportion. So let's set it up. 50 feet over 60 feet should be equal to x over 80 minus x. So I'm going to go ahead and divide 50 and 60 by 10, just to simplify that fraction a little bit there. And then now we can go ahead and solve. This will give us 6x is equal to 5 times 80 minus x. Then we can distribute, add 5x, and then divide by 11. And we get x is approximately 36.4 feet. So that's this distance right here from the art museum and on the side of the street. So she wants to park so that her total distance directly to each building is the shortest. So we can say that she should park approximately 36.4 feet on the street closest to the art museum. Question 57, write an equation for each of the following sequences. So on sequence A, we are adding 20 over and over again, so that's a arithmetic sequence. And there's different ways that you can write it. You can use an explicit form, recursive form. This one I'll write a couple different ways so you can see, but T of n is equal to 20 times n, because that's what you're adding each time, and then you'd actually have to go back to term 0. Let's say n equals 0, and that would also be a 20, so that would be plus 20. So that's one way to do it. You could use the first term form, so you don't have to go back to term 0, and you could still do, but it would be 20 times n minus 1, and then plus 40. So if I was looking for the first term, it'd be 20 times 0, and then you'd do plus 40, so it would be 40. And then the second term would then go to 60 and 80 and so on. Remember, you can also, instead of T of n, you can use the form A of n. So you could do A of n equals 20n plus 20. Same idea there. Part B. So how do you get from 3 to, this is 3 over 1, to 3 over 2, to 3 over 4? And you would be multiplying by 1/2 each time. And remember, you can work backwards to find that out. You can take 3/2 divided by 3, 3/4 divided by 3/2 to figure out what that multiplier is. And so once again, we have T of n is equal to, and if I go back a term, that would be 6, so I could rewrite it as 1/2 raised to the n power, because that's what's being multiplied over and over again, times 6, or 6. If you want to put the 6 in front, it could look like that too. We could also do first term form, so we wouldn't have to go back. Be the same thing, but the first term is 3, and then 1/2 raised to the n minus 1. And then also don't forget we can use A of n just like I did in the last one. So that is how you write equations of sequences. The first one's arithmetic, the second one's geometric. Question 58. Earl still hates to wash the dishes and take out the garbage. He found his own weighted coin, one that would randomly land on heads 30% of the time. He will flip a coin once for each chore, and will perform the chore if the coin lands on heads. What is the probability that Earl will get out of doing both chores? Alright, went ahead and set up the area model, and so what you notice, heads is 30%, tails is 70%, and so I'm going to go ahead and multiply each of these so we can see what the percent or the decimal is for the probability of each of these occurring. Alright, so we have the percentages 9%, 21%, 21%, and 49% written as decimals. And now, what is the probability that Earl will get out of doing both chores? Well, for him to get out of doing both chores, he would have to flip a tails both times. And so for a tails to occur both times would be right here, and that would be at 49%. So the probability that Earl will get out of doing both chores would be 49%. On the next probability, it wants to know what is the probability that Earl will have to take out the garbage, but will need to wash the dishes. So you can look at it, it doesn't matter necessarily the order here as to how it happens, but he would have to flip either a heads, and then a tails, which would put you at 21%, or, a heads and then a tails this way, which is still 21%. So either way it happens, whether it's having to do the garbage, not the dishes, or the dishes and not the garbage. Either one's going to be 21%. Question 59. Which pairs of triangles below are congruent and or similar? For each part, explain how you know using the appropriate triangle congruency or similarity condition. The diagrams are not necessarily drawn to scale. So on part A, they're definitely not congruent. You can tell the side lengths are not the same, so we just need to check for similarity, and that's if they have the same ratio. So let's take the smallest side of the triangle on the right and pair it up with the smallest side on the one on the left, so it'd be 2/6. The next one would be the middle number, which would be 4/12, and then the largest side length, which would be 5/15. So 2/6 reduces to 1/3, 4/12 reduces to 1/3, and 5/15 reduces to 1/3. So they are similar, and that would be by the side similarity. Part B. We have two triangles. Both have 6 centimeters as a side length. A couple different angles. Let's go ahead and find the third angle. The third angle on the first triangle would be 48 degrees, and the third angle on the second triangle would be 112 degrees. We do know that this side between 112 and 48 degrees on both triangles is both 6. So we could look at this as an side angle, because we have 48 degrees. We have the 112 degrees. And then we have the side length in between them. So yes, these are congruent by angle, side, angle congruency. So angle, side, angle congruency. Alright, part C. We have two right triangles. So we have one leg is 12. And another one of the legs is 12. We have a 13 as a hypotenuse on that one, and a 5 as a leg. So let's go ahead and do Pythagorean theorem, unless you remember maybe some of your Pythagorean triples here. But the first one would be 12 squared plus x squared is equal to 13 squared. And that would leave us with x squared is equal to 169 minus 144, so that'd be 25. So x is equal to 5, so that'd be that one. And on the next one, you have 5 squared plus 12 squared is equal to y squared. So that's 25 plus your 144, and that would be 169. So y is equal to 13. So we see that all three sides are the same, so we know this is congruent by side congruency. And for part D, we have two angles that are congruent, the 48, the 62, and then obviously the third one would be congruent as well. But be careful on this one. This 12 is in between the 48 and 62 on this triangle, but on this one it's the 62 degrees in the other angle. So those are not the same sides that we're looking at. So the best we can do on this one is say that they are similar, and they would be similar by angle similarity. And just a reminder, if they are congruent, because it does kind of go back to the directions here, which pairs of triangles below are congruent and or similar? So if they're congruent, they're also similar. So that would be the second and the third one. So all four of them are similar in their pairs, but B and C would be congruent and similar. Question 60. For part B of problem 7-59, the one we just did, explain how the triangles are congruent using a sequence of rigid transformations. So we could probably look at this a couple different ways. Remember, this is 112 degrees here, and this is 48 degrees here. It does appear on this one, I think, that we could take this triangle and rotate it clockwise, and that would kind of move the 48 over here, the 20 degrees to the other one, and then you could just translate it to match it up with that triangle. So I would say a rotation followed by a translation.